Hi friends, today in this video we are going to see one of the important building material called cement. Cement is a binder, is a substance that sets and hardens and can bind the other materials together. Cement can be characterized as being hydraulic or non-hydraulic depend upon the ability of the cement to be used in the presence of water. Hydraulic cement. Hydraulic cements are used in the wet conditions, underwater, further protects the hardened material from the chemical attack. And non-hydraulic cement used in dry condition and react with the carbon dioxide in the air. Some of the uses of the cements are masonry work, plastering, pointing, flooring, roofs, construction lintels, beams, weather shed, stairs, pillars, bridge culverts, dams, tunnels, lighthouse clocks, etc. and water wells, tennis courts, septic tanks, lamppost, telephone cabins, etc. Precast pipes, garden seats, artistically purpose, flower pots, watertight floors, food paths, etc. The ingredient of cement are calcareous, argillaceous and the gypsum. Calcareous means the calcium carbonate, which is lime. Argillaceous means clay stone, which is alumina, silica, iron oxide, etc. And the third one is gypsum. So these two can explain the dry process of the manufacturing of cement and wet process of the manufacturing of cement. So the main difference between the dry process and wet process is this water. So both are the same in process, but the water could be added extra in the wet process. So here the limestone is added to the crusher and the shale is added and the ball mill for crushing, and it is taken to the rotatory kilns, and there the pulverized coals are added. Then the clinker will cool and the gypsum is added last, and ball mill will send the cement to the cement silos, and there to the hoppers, and there to the transport. So the same process is carried out in wet, but these are added with the water. So only dry materials are taken in the dry process. Here the slurries are taken in the wet process. So the oxides of compositions in the cement are follows. The first one is lime. It is 60 to 65% of weight of the cement, and its function is to control soundness and strength. A deficiency of lime will causes the cement to set quickly and lower the strength of the cement. If it presents in excess, makes the cement unsound and causes the cement to expand and disintegrate. The second one is silica. Silica should be in the range of 20 to 25% of weight of cement, and its function is to give strength. If it presents in excess, it causes the cement to get strength, but at the same time the setting time of the cement is prolonged. Alumina. Alumina should be in the range of 4 to 8%, and it is responsible for quick setting property, and it also lower the clinker temperature. If it present in excess, it causes the weakens cement. Iron oxide. Iron oxide should be in the range of 2 to 4%. It impart color, hardness, and also helps in fusion of raw materials during manufacturing of cement. Magnesium oxide. Magnesium oxide in the range of 1 to 3% should be added, and it impart color and hardness, and if it presents in excess, it causes the cement unsound. Sulfur trioxide. Sulfur trioxide should be in the range of 0 to 3%, and its function is to make the cement sound, and if it present in excess, it makes the cement unsound. Soda and potash. Soda and potash should not be added externally. If it present in the cement, it should be in the range of 0.4 to 1.3%. There is no function of the soda and potash, and if it present in excess of 1.3%, it causes the efflorescence and cracking of the cement structure. The last one is gypsum. Gypsum should be in the range of 2 to 3%. It delay the setting time, and if it present in excess, it fastens the setting time. So the important notes are, without adding the gypsum, if the water is added to the cement, then it is known as flash set. To overcome this flash set only, the gypsum is added in the optimum level. Alumina or iron oxide act as a flux. to reduce the clinker temperature. And when lime is added more than the required quantity, the free lime which is at the construction site will react with the water and causes slacking, which means it expands in size and causes the cracks. So these oxides of compounds are combined by the scientist name called Boggy and named the 4 compounds called tricalcium silicate, dicalcium silicate, tetracalcium aluminoferrite and tricalcium aluminate. So it should be in the range of C3A should be in the range of 40 to 45%, and it is responsible for early strength. The first 7-day strength is given by this C3S, and it produces more heat of hydration and causes less resistance to sulfate attack. The second one is dicalcium silicate. Dicalcium silicate should be in the range of 20 to 30%, and it is responsible for later strength. It produces less heat of hydration and it is more resistant to the sulfate attack. This is more important point. It is more resistant to the sulfate attack. And tricalcium silicate. Tricalcium silicate in the range of 11%, and this is the first compound react with the water and lead to flash set, and it is responsible for quick setting property. It is the most heat of hydration producing property, and it is responsible for undesirable properties of the cement. Tetracalcium aluminiferrate, it should be in the range of 9%, and it shows comparatively high resistance to sulfate attack than C3A, and the reaction of C4AF phase are slower and evolve less heat than C3A. Hydration of cement. What is meant by hydration of cement? It is the chemical reaction between the cement and the water. The instrument used is calorimeter and vacuum flash test. Unit of hydration is calories per gram or joules per gram. So the heat of hydration of the Boggy compound in decreasing order are: first one C3A, which has high high rate of hydration, and C3S, C4AF, C2S. Tricalcium aluminate has the amount of heat of hydration has 865, and tricalcium has 500, tetracalcium aluminiferrate has 420, and dicalcium silicate has 260, and because of this reason it is having the less resistance to sulfate attack. So the products of hydration. What are all the products of hydration? Calcium silicate hydrate. It is not only the most abundant reaction product, it also occupying the 50% of the paste volume, and it is responsible for the engineering properties of the cement paste, and it is often abbreviated as CSH gel. Calcium hydroxide. The other products of hydration are calcium hydroxide, and this is contrasted to CSH because it constitutes only 20 to 25% of volume of solids in hydrated paste, and this results in lack of durability, causes the sulfate attack, which means these CaOH react with the sulfates in the soils and water, form calcium sulfate, which further react with the C3A in the cement and causes deterioration to the concrete. So that is called as sulfate attack. To reduce these concentration of CaOH, blending materials like fly ash, silica fume, other pozzolanic materials are used. However, it is alkaline in nature, and due to this it acts as a resistance for the corrosion in the steel. Calcium aluminium hydrates. These are the compounds formed due to the hydration of C3A compounds. The hydrates aluminates do not contribute anything to the strength, but its presence is harmful for the durability of concrete, particularly where the concrete is likely to be attacked by sulfates. So where it is attacked by sulfates in the seaside region and underwater construction, so in that regions the concrete is likely to be attacked by sulfates, and as it hydrates very fast, it may contribute a little to the earlier strength. So earlier strength is responsible by the calcium aluminium hydrates. So the role of the gypsum. Role of the gypsum is very important because it controls the initial setting time. So the percentage gypsum increases, setting time increases and sets slowly. So it acts as a retarder and prolong the setting. So the role of the gypsum is of two types. It controls the flash set and causes the false set. So it retards when optimum quantity of 2 to 3% of gypsum is added, and if added excess quantity that is greater than 5%, it causes abnormal premature stiffening of cement, and within few minutes mixing of water it causes false set. Water requirement for hydration. C3S requires 24% and C2S requires 21% of water. So average of 23% of water by weight of the cement is required for the chemical reaction, and it is also called as bound water. So extra 15% of water of weight of the cement is required to fill up the pores like gel pores, capillary pores, micropores. Totally water requirement for hydration is 38%. If more than this 38% is added, capillary pores will develop, and highest code recommended that maximum water cement ratio is 0.4% for the water requirement for hydration. And that's all for today's video, friends. Like my video and comment your comments in the comment box. Subscribe my YouTube channel and press the bell icon for the regular updates of videos. Share this video with your friends. Thank you.